Hi, I got cut off there. Too much talking. So the whisking creates this heat because of friction, and it sets the egg white or the egg albumin, and it forms a temporary foam. So this will collapse after a while. So say you whisk for a meringue, and it's all lovely. You can turn the bowl upside down. Sorry, I came upstairs. It won't fall on your head, but after a while, the air will evaporate, and you're left with a watery substance. So unless you heat it in the oven and cook it, it will set as a permanent foam. And our examples there are meringues and sponges because you spend so much time whisking the air into them. Okay, now the Maillard reaction. This is the reaction between sugars and amino acids. Okay, and it causes browning. And another name that is for the Maillard reaction is non-enzymic browning, funnily enough. Okay, so there's no enzymes involved, like an apple. You cut an apple open, the enzymes react with the oxygen in the air, and you get browning. This has nothing to do with that. This is a chemical reaction between proteins or amino acids and carbs, okay, or sugars. And it's in dry heat, so in the oven. Okay, it produces an attractive brown color, so you can see that here in these lovely biscuits, and a crust with an appetizing flavor. Okay, so an example then would be shortbread biscuits. Roast potatoes go brown because of the reaction between the two, and as does roast meat as well. Okay, now caramelization, creating of caramel. On heating, sugar melts and it caramelizes. So if you put sugar into a saucepan and put it onto a heat, eventually it will melt, caramelize. And this occurs over 10 gradual stages between 104 degrees and 177. So you could have a sugar thermometer there, and that will give you the different temperatures for yourself. Sugar thermometers go above, like a normal thermometer goes to about 100. Sugar thermometers go way up. Caramelization normally occurs, you can underline this if you haven't, I'm sure we have 160 degrees. And this results in an attractive brown color like this and a sweet taste. But if it is overheated, so it goes above 177 degrees, the caramel will carbonize or burn, okay, and it won't be nice, it'll be discolored, and it goes hard and it just doesn't taste nice. So an example of using caramelization in cookery is creating creme caramel, which is custard with a layer of caramel on top, or the millionaire shortbread or caramel squares, just like a Twix. So you have your shortbread on the bottom, caramel in the middle, and your chocolate on the top. Okay. Now, crystallization. If I had a cup of tea and I was adding sugar to it, and I've kept adding sugar upon sugar upon sugar, eventually there wouldn't be enough liquid to absorb the sugar, and we would say that it is saturated with sugar. Okay, so when a liquid has dissolved as much sugar as it can, it is saturated. Okay, so if I kept adding my sugar to the tea and over 25 spoons, eventually I wouldn't have enough tea to absorb it. If more sugar is added, then crystals of sugar form in the solution. So eventually what will happen is the sugar will solidify when cooled. Okay, so big crystals of sugar will form and solidify, and you'll end up with this crunchiness. So confectionery, like sweets and that kind of thing, is one culinary application, and fudge would be another. Okay. Now, last one as regards hydrolysis. Hydrolysis, which is the reverse of the condensation reaction, occurs during digestion. Water and enzymes split disaccharides into two. Okay, so we eat our disaccharides. Enzymes break them back down. So lactose, for instance, turns into glucose and galactose. And finally, then inversion. Now, inversion sugars is an excellent thing for us to eat for sweets. Inverting sugars makes them sweeter, and that's the bottom line here. Okay, so inversion occurs when a sweet liquid sucrose solution, so liquid sugar, is heated in the presence of an acid or an enzyme. So, for example, jam, you add lemon juice, or the berries are slightly acidic, or enzyme, and this causes the sucrose, which is a disaccharide, two sugar units, splits up, and it inverts back to being glucose and fructose. Okay, and these are monosaccharides. So when the disaccharide is forced to split back into its monosaccharides, they're known as invert sugars, and they are sweeter. So glucose and fructose are far sweeter than sucrose, and that's brilliant then for jam. It's brilliant then for confectionery as well. So any of those boiled sweets, such as a strepsil, they're all inverted sugars, and even though they're good for your throat, they're horrendously sweet. because of this inversion that they use. Okay, so inversion then is just splitting disaccharides into their component monosaccharides, and they become sweeter. Now, properties of starch then. I know I went quite fast, but as I said, you can stop and start me. You can write down questions for me as well. It's just to give you a little kind of quick headspace on these again, because it has been a while since we've done them. All right, so since we have done them. Properties of starch: it is a non-crystalline powder. It is insoluble. So if I throw my potato into a saucepan of cold water, nothing will happen because it is insoluble in cold water. And starch is not sweet. So there are two good ones, nice and short, but they're still valid properties. Now, hygroscopy, we talk about this all the time. You leave the lid of open the packet of biscuits and leave them open. You drop your phone in water, you put it into rice. And the reason for this is hygroscopy. Starch is hygroscopic, and this means it has the ability to absorb moisture from the air. So this causes uncovered foods like biscuits to soften and to lose crunch. So you couldn't use the example of mobile phone in rice as your example here because we're looking for culinary examples, but that's why we do it. The rice absorbs the water out of the phone. Okay, so the culinary application of hygroscopic, of starch being hygroscopic, is that it helps keeps cake moist and prevents them from drying out. That's why we use flour, etc. Now, gelatinization. When starch is combined with a liquid and heated to 55 to 70 degrees, the grains swell, they burst, and they absorb the liquid around them. And this here would be an example of our roux sauces. Okay, popcorn would be another one with dry heat. And when this happens, if you have flour in liquid and they swell, burst, and absorb, it makes them thick. That's what it means by increasing the viscosity. So a sauce you're making for your mac and cheese or your lasagna is going to be that's very thick, that's very viscous compared to just the milkiness of it was at the beginning. As that temperature then increases above 85, it becomes even more viscous. It gets thicker and thicker. And at this stage, it forms a sol. Okay, so as it's coming to the boil, just before boiling point, you'd say that the roux sauce has formed a sol. And when the mixture cools, you turn it down, it boils and it turns down. The water molecules have become trapped at this stage. The thickness is there. You have formed a gel. Okay, so in your culinary application then, the moist heat would be a roux sauce, equal quantities of fat and flour with varying amounts of liquid. And then lemon curd is another one. Lemon juice and ice and sugar, and they use a thickener there. And then dry heat would be a popcorn or pastry. So pastry, it's where the fat is absorbed by the starch cells in the flour because pastry is such a high fat food. Now, finally then, hydrolysis and dextrinization. So on this scale here, I think I'd be this one. And everyone is different. There's loads of different types of toast in between. So hydrolysis, I'll come back to that in dextrinization. Sorry, I got carried away with the photo. Hydrolysis then is the reverse of the condensation reaction, and it occurs during digestion. Water and the enzymes in our stomach not in our stomach, but in our digestive system, split starches, polysaccharides, into the disaccharide maltose. Okay, so starch becomes maltose, and then maltose gets broken down into glucose and glucose. And finally then, dextrinization. When starch foods are dry heated, short chain polysaccharides called dextrins are formed. So you put your bread in the toaster, heat comes, and the long chain polysaccharides in the bread shorten to become dextrins. And as they further heat, they combine to form pyrodextrins. Okay, and this causes a color change on the surface of the food, resulting in an attractive brown appearance. But if too many pyrodextrins form, you end up with your burnt toast. Okay, and always, dextrinization, we use the burning of bread to make toast as our example. Okay, now finally then, I'm just going to check my time again. 9, okay, I have loads of time. Properties of non-starch polysaccharides. So dietary fiber is an example of a non-starch polysaccharide. Okay, they can also be called, it's gone blank on me. Roughage, that's it. Cellulose as well is another word for it. Okay, in a question, they might call it non-starch polysaccharide. They might call it You know, any of these are non-starch polysaccharides. Fiber might be called cellulose, it might be called roughage. And as we know, fiber is insoluble in water, and we don't have enzymes to break it down, so it cannot be digested by the body, but it does absorb water as it passes through the intestinal tract. So I always say, think of Weetabix in this case. Weetabix is dry, but when you add liquid to it, it sucks it in and becomes soft. Okay, so our waste is like that. It absorbs water, becomes soft, and this helps stimulate the peristaltic movement. It's like a worm moving. So it's a wave-like movement caused by the muscles of the large intestine contracting, which is getting smaller, and relaxing is going back to normal. This benefits the body because it speeds up the passage of food and waste, and this prevents bowel disorders like constipation. So constipation is where you just have trouble expelling your waste. Okay, so we should be getting about 30 grams of fiber every day in our diet. We're not in Ireland. On average, we're getting about 12, which isn't good for our bowels. Now, gums are next. They are soluble in water. So ice cream is an example of a food that contains gums. They have the ability to absorb large amounts of water to form a thick gel with a firm texture. And our examples here are salad dressings and ice cream. Okay. And remember I said carrageenan is an example of a gum. And finally then, pectin. Now we've come across pectin again in our jam making. Pectin is naturally present in plant cells and the cell walls of fruit and veg. It is used as a setting agent, as it has the ability to absorb water to form a gel. It is only present in fruits when they are ripe, and in underripe fruits it is in the form of protopectin, and in overripe fruits it becomes pectic acid. So we can deduce from that the best type of fruit then is ripe fruit. Ripe fruit are the only ones that contain the actual pectin we need. Underripe fruits contain protopectin, which doesn't set, and overripe fruits contain pectic acid, that doesn't help set. So for pectin as well to be extracted, it needs heat and acid. So when we're making jam, we will use lemon juice as well. And pectin is always used as regards jam making. All right. Now, gone way too far as well. So that is me, I think. You can read over the rest of it and see if there's any questions you have. All right. And you can make sure you know your enzymes and things like that as well. Okay, you might be asked in a short question or in a part of a question to talk about the enzymes, etc. All right, talk to you.